Hello there. We've come to the end. We're now looking at that final important part where, after you've a question has arisen, you've come up with a hypothesis, you've gone out and collected the data, you've organized the data, you've analyzed it, you've even drawn graphs, as the authors of this data handling exercise have done here. Now you've got to put pen to paper and come up with a conclusion. Now, if the type of question was a comparison one and the data was qualitative, then there's really not much more we can do other than to say which was the most popular and which was the least. Let's look here. It's an example of qualitative data that's been gathered and then organized into and displayed using a pie chart. The question was, how long do you think the coalition will last? 23% said less than a year, 13% said don't know, 12% said 5 or more years, 13% said 3 or 4 years, and 38%, the largest sector, said 1 or 2 years. So your conclusion would literally be this: the most popular belief, because that's what people are doing, they're being asked how long they think, they believe the coalition will last. What belief is that? The coalition will last 1 or 2 years. If you wanted to say more, you might then talk about which was the least most popular. The least popular was 5 years or more. The only other thing you could do is to look at what the majority of people thought. Now, if we look at the majority, that's more than half. We can see that 23% add 38% is 61%. So 61% said. Now what we've got to do is sum up these two sectors, 1 or 2 years, less than a year. So 61% said 2 years or less. So when it comes to making comparisons, drawing our conclusions, when it comes to a comparison type question, really we're going to talk about which thing was the most popular, which was the least, and then perhaps, if we've got the data, talk about what the majority felt or appreciated or wanted or what have you. Now, let's look at one you're more likely to face in an exam. It's a conclusion and it's a comparison type question, but this time the data was quantitative. Let's say it's all about the height of Year 8 pupils. Now, we've analyzed it and we've found the average, in this case the mean average, and we've also found the range. And for boys, let's say the average was 1.57 meters. For girls, it was 1.39 meters. The range for boys was 0.42 meters, and for girls it was 0.49 meters. So what can we say? Well, we have to use this key phrase here. We begin with on average. Who was taller? Well, the mean for boys was 1.57. The mean for girls was 1.39. So on average, boys were taller than girls. That's our assertion, and it's only an assertion until we add evidence. And here's our evidence. Mean of 1.57 meters compared to 1.39 meters. But there's a second thing we can talk about. We can look at and think about what this means. The fact that the range for boys was 0.42 meters and that for girls was 0.49. What does that mean? Well, it means the range measures spread, how spread out the heights were. Now, if we see that girls had a higher range, so therefore the height of girls was more spread out. And again, we back up our assertion with some evidence. Range 0.49 meters compared 0.42 meters. Well, that's one way of wording it, but we could look at it the other way around. We could say that the boys' height was less spread out. Just get rid of all this. So we could word it thus. The height of boys was less spread out. Now there's another word that saves us having to write the word spread out. The height of boys was more consistent. Consistent means it doesn't vary much. The more consistent something is, the less it's spread out, the less the range. Now, range of 0.42 meters compared to 0.49 meters. Yeah, to prove that the consistency was greater, we have to show that the range was less. The lower the range, the more consistent. So that's how we draw our conclusions when it comes to comparison questions. We're finally going to look at what conclusions can we draw when we're looking at a linking type question. Well, basically it's this. This is an examination of the link between the age in years and the percentage of fat in the human body. And our conclusion would be something along these lines. As a person gets older, on average, the percentage of fat increases. That's one way of writing it. A slightly more a scientific way, or using more technical languages, there is a positive correlation. Between age and percentage of fat. As one grows, so does the other. As one decreases, if we look, the younger people have less fat. They're going in the same direction, so it's a positive correlation. Okay, that's it really. That's the final part of this course on data handling. And just to recap, we've looked at how the questions are, or the type of questions that can arise, how and what our hypothesis is, how we go out and collect the data, how we organize and analyze the data, how we display and interpret the data, and finally this little bit here, we've looked at the conclusions we can draw from the data. Anyway, thank you for listening so attentively.